Hello everyone, so tonight we're going to do a test on our heat pump. It's a 12,000 BTU heat pump, and I'm going to test the wattage draw this time with cold weather. I previously did it when it was very hot outside. Now I'm going to do it when it's very cold outside, and this is cold outside for my area. So I'm down in South Carolina. So you can see it's about 45 right now, and it's going to go down into the mid to high 20s, and it'll probably stay in the 30s. So I should say right now it's about 9 p.m. and if you look at tomorrow, I think it goes up to a high of 40, low 40s, and then back down in the 30s. And this is probably going to be one of the coldest nights of the year. So I try to figure what kind of wattage this is going to take over a 24-hour period. So what we're going to do here is go outside and reset the timer, and then we're going to turn the heat pump on, and we're going to probably leave it on, let's just say 74 degrees, somewhere in the low 70s. Maybe we'll put it on I don't know, maybe we'll put it on 70 degrees. So we're gonna do two things really to see how well the heat pump works in the 20s when it's 20 outside. So we'll check on this tomorrow morning because it is, like I said, it's around 9 p.m. And when we get up in the morning, it should be in the 20s. So we'll go out there and we'll see how well it's heating, and we'll see what the wattage draw is. So what I'm gonna do is go ahead and turn it on, then go outside and do an initial reset and check to see what the voltages and amperage draw is. Okay, so you can see we're running at about 244 volts and about 4.94 amps. So we're drawing about 1.2 kilowatts. I just turned the unit on. I've seen this go up to 1.5. I just turned it on, so it'll probably build its way up in a little bit. And what I might do is see it going up right now, and we'll just wait here for a few minutes. I should also show you that it's almost 9 o'clock, so I'm just starting this test right now. So what we'll do is we'll check on this in the morning, and then we'll check on it after 24 hours. And we'll check on it periodically throughout the day as well. You can see we're hovering right around 1.37 kilowatts. And the power factor is at 0.99, so. And if you think about it, this is about what a space heater draws, about 1,500 watts. And a space heater only puts out maybe 5,000 BTUs. And this Minisplit is a 12,000 BTU. So you can see how much more efficient it is. Alright, so it's the next morning. It's about 8:30 in the morning, which is almost 12 hours. It got down to, I'm guessing, mid-20s last night. I know this thing was on all night. And we'll We're gonna try to look at the numbers here. So you can see right now we're running at 355 watts. And we used almost 4 kilowatts so far. 3.94 kilowatts. And the air's coming out, it's cold. Alright, so I'm back at the 24-hour mark. You can see it's almost 9 o'clock on Wednesday night. It's about 36 degrees. It is actually really cold out here. So this has been running for 24 hours. So you can see right there, it's using about 420 watts. And we've got 10 kilowatt hours. So what that means is over a 24-hour period, we were averaging 416 watts an hour. So you can see how efficient this is compared to even like a space heater. We have another cold night coming on Saturday. I think it's supposed to get down into the low 20s. So I'm gonna run this test again just to see if I get a consistent reading or something similar to this. So we'll continue this in a few days, and we'll see how many watts this uses for the 2 different days. All right, well, good morning. This is test 2, and it is Saturday, January 20th, 7:30 in the morning, and it's 29 degrees out here. And I chose today because it is supposed to be only going to the 30s today, and then in the afternoon and evening it drops back into the 20s, and then the low 20s at night. So we're gonna get a good test here in the 20s for South Carolina. This is a little unusual. Okay, so we just got it turned on, and you can see here it's ramping up. It's getting a little louder as it ramps. So someone asked me the question, how many incoming watts, what's the surge rating of this unit? And because this is an inverter unit, it doesn't really work that way. You can see here how it's ramping up. So it doesn't just go from like 0 watts to 1500 watts in a second. That's the nice thing about these inverter units, is the fact that they ramp up. So that was interesting how it just dropped as it was going up. It just shut off. One weird thing I noticed too, when I did this, I don't know, it was pulled out before, I don't know, maybe a month or so back, is it seemed to go in defrost mode before it actually came on. Like it wanted to, maybe from sitting all night, it feels like it needs to defrost itself. So we're gonna actually keep our eye out, because I was curious what it actually used in defrost mode. So right now it is off, but I do believe it's in defrost mode. So we're gonna see what it does here in defrost mode. You can actually hear it. I don't know if you can hear that noise, but something's ramping up in there. And notice that the fan's not even on. But anyway, let's get back to this. So this is what it's going to use when it feels like it needs to defrost itself, because in the wintertime it'll often do this depending on how cold it is. Right now my fingers are actually really freezing. I mean, it is, like I said, 29 degrees out here. Still not, the fan did not come on yet. You can still hear it ramping up. Okay, now that just clicked off. You can hear the unit. Now the fan came on. So that sequence used about 1,000 watts when it was doing that. Now I'm gonna guess it's gonna go into its normal run phase. I did turn it up to 78 degrees in there. It was, whatever the room would have been last night, probably in the 40s to 50s maybe. That room is actually shut off from the rest of the house at night. So we're gonna let this ramp up here, and I believe when I did this the other day, it was somewhere around, well, it varied, but on average, I think we calculated it out to be around 419 watts an hour. Like I said, when this first comes on, because the room's so cold, it's gonna get up to 1,500 watts. So I do believe this will climb right around a little over 1,500 watts. And then once that room kind of gets normalized, it seems to average around 400 watts. Keep switching hands because it's freezing out here. Now again, my unit is a Senville Aura. I'll give you the specs here. So it's a 12,000 BTU, and this is supposedly the high efficiency model. You can see it runs on 240 volts. I used it a lot this summer, and I love it. Keeps the room really comfortable. Is able to actually keep the house at a stable temperature if the main AC ever went down. And in the wintertime, when I ran the test the other day, it actually, at nighttime, it was actually able to keep the house, I want to say 67 degrees. It kept the main house with the inside unit turned up. Sorry, with the heat pump turned up. I think I went to bed, I had set to 74. And it kept the entire house at 67 when the main was off. And we're gonna try that again tonight. We're gonna set the main unit for, right around 69 degrees. And we're gonna leave this run. The ultimate goal there really is, like I said, the main unit does not work when it gets into the low 30s, like 31, 32. It just doesn't keep up. It just runs all the time. So you can still see here we're still ramping up. Like I said, I believe it'll get a little past 1.5. It may go higher, I don't know. That's what I'm kind of curious to see, is how high it's gonna go. So you can see it kind of looks like it hit the 1.5 and then it backed off to 1.3. Now on the nameplate it said it uses 9.96 amps, but you can see here more realistically it's around 6 amps that it uses when it's running at full bore. So the nameplates are always usually a little bit higher than what the units actually do. I'm just going to let it go for a little bit more, but I don't think it's going to go over higher than that 1.5 kilowatts. And we actually got to see it kind of in a defrost startup mode there, where looks like it peaked out as well. So right now I'm running, when I power this via solar and batteries, I'm running well, for the air conditioning I ran a 1500 watt inverter, but that didn't work on this in the winter, and I think it's because it hits exactly 1.5, and because of the currency efficiency losses I actually had to jump up to a 3000 watt inverter for the winter time. There it goes a little higher, 1.55, and that's the reason right there, is because it's using 1550 watts and my inverter was only rated for 1500. So to make this work in the winter time with a smaller inverter, probably would need a 2000 watt inverter. So you know, you'd have a little bit of buffer room there from hitting the roof. I'm gonna let this go because this is the highest I've seen it run. Maybe it'll hit 1600 watts. But when you think about this, even if this hits 1600 watts, that's the actual amount of watts that a small space heater uses, those small electric space heaters. And those things barely keep anything warm. This is actually keeping that entire room in there, which is like a 12 by 22 room, unbelievably warm, and it's actually putting heat out into the rest of the house. So now we're at the 6.8 on the current. So remember the nameplate said 9 point something, I just said a few seconds ago. Well, wasn't too far from that number. But this is why my 1500 watt inverter failed to work in the cool mode. Now in the heat mode it actually, I'm sorry, in the cool mode it actually works great. I've never seen a trip, so it must never go over 1500 watts, but you can see right here how we're using 1640 watts. Glad I ran this test because now I can actually see what it's running here. Now it's up to 1800 watts. I'll probably stay with my 3000 watt inverter on this then, just to have that headroom. You know, really don't ever want to run an inverter to its peak setting. So if I bought a 2000 watt inverter, this is pretty darn close to hitting 2000 watts. And we're running 1890 watts right here at almost 8 amps of current. There it is, 1900 watts. Switching hands, it's so cold out here. See if we can get the 2000. To hear the noise of this, it actually sounds like it's at its highest. It doesn't sound like it can go much higher. It keeps going, huh? Will we get to 2? Looks like it's kind of peaked. Just gonna get out here and feel the lines real quick. That line is nice and hot. Yeah, it's nice and hot. I don't think it's gonna get much hotter than that. Wow, hit an 8.21 amps. I'm really glad I did this test. I mean, I guess there's a little room there too. We're not in a cold area, but if I had this up in the north, I wonder if it would go any higher. Maybe it would use those full 9.5 amps or whatever it's called on the nameplate. I'm not sure. It's pretty darn close to it now. So we hit a peak of 1.95 kilowatts. So 1950 watts. Well, there we go, 1.96. This thing is cranking away. There you go, 1.97. Ooh, a new high, 1.98. Oh, 1.99. Will we hit 2? Back down. That's probably as high as it's gonna hit here today. So what I'm gonna do is probably check in on this unit every couple hours, but I do believe once that room gets warmed up, it'll stay at around 415 watts. So it'll drop down considerably. I don't think we're gonna hit the 2,000 kilowatt mark. I'll give it one last show note. I was gonna do it there. That's really high. This little unit is cranking away. Maybe we'll hit it. It's not gonna do it. It's gonna make me freeze. Well, there it is. 2 kilowatts. That's what I wanted to see. So even a 2,000 watt inverter would not work. So you'd either need a 2,500 watt inverter or a 3,000 watt inverter. To stay on the safe side, just get a 3000 watt inverter. This is, I didn't think it would go any higher, 2.02. Just think if I was running one of those 12 volt 105 amp hour batteries, they give around, I want to say around 1250 watt hours. Be like a third of the way through that battery already, and we've only been running for like 20 minutes, maybe 25 minutes. There's a new limit, 2.05. New limit, 2.06. Alright, so cold, I'm going in. Alright, here we are. A little over 2 hours into it. You can see we're up to 33 degrees now. I still have the heat pump set for like 78 degrees, and you can see, hopefully you can see that, we're using 1.45 kilowatts right now, so we're using about 1400 watts. Alright, so it is 1 o'clock on Saturday, 37 degrees out, so it's still really cold. And you can see now we're using 623 watts, and we used 5.25 kilowatt hours since we started this experiment. We'll check back in a little bit. Alright, so you can see the temperature is 36. The time was right around 5:15 p.m. So it is getting relatively cold. Well, it's been cold, but it's getting a little colder. And there you can see we're using about 700 watts. I still have the unit set for about 78 degrees in the house. So you can see we used about 7.79 kilowatt hours, and currently we're using 700 watts. Okay, so here we are, 7:30, almost 7:30 at night, 32 degrees. So this has been running about 12 hours, and you can see those numbers there. We're using about 623 watts, and energy is at 9 kilowatts. So if you remember the day before, we were at 4 kilowatts hours at the 12-hour mark. So we used considerably more this day, partially because I have the heat up at 78. I set 78 in there. I believe the other night I had it set to 74. So I will turn it down to 74 at night, and we'll let this run till 7:30 in the morning, and we'll see the total kilowatt hours consumed for this day. And again, it appears to be definitely colder out, especially with the wind chill factor involved today. So it didn't get much out of the 30s today at all, and right now it's 32, so it's technically freezing out, and it's only going to drop into the 20s tonight. So we'll check this out again tomorrow morning. Alright, so it's 7:30 in the morning on Sunday the 21st, and it's 22 degrees out. It was probably in the 20s most of the night past midnight. Really cold. Let's do a final look here. So this is 24-hour runtime in about 30 degree daytime, 20 degree nighttime temperatures. So you can see the unit right now is probably actually gonna shut off and defrost. Just shut off. So it's probably gonna go into a defrost mode, but you can see there we use 16
16,000, well basically 16,000 kilowatts. So basically this particular day and night, it ravaged around 666 watts an hour over 24 hours, which is still really efficient if you think about it. I did have the main house set at 68, and I had the mini split here set at 74, and the house stayed at 68. Now the main did come on a few times, especially after 2 a.m. Yeah, you can hear it's going into defrost mode. So we'll just check this again, because yesterday it was at 1,000. It peaked at 1,000 watts in defrost mode, and you can see the fan is not on. It's kind of hard for you to see that, but the fan is not spinning. And these mini splits and all kind of heat pumps will do this, and when it's really cold out, it kind of has to heat up everything, and then once it's done, it goes back into normal heat pump mode. But let's just take a look. Like I said, yesterday it got to 1,000 watts in the kind of like the defrost mode. See what happens here. I don't know if you can hear that on the mic, but it's ramping up. You can kind of hear it slowly increasing, and then let's see how high it goes here. Yep, that's about as high as it got yesterday, right around 1,000 watts. And then it's going to come down, and then I believe it's going to start back up. Yep, so it starts back up. Alright, so this concludes the 24-hour test in 30-degree daytime, 20-degree nighttime temperatures. It's not going to get much colder than that down here in South Carolina. So it looks like a worst-case scenario, about 16,000 watts over a 24-hour period.